So the big picture for this lesson is graphing quadratic functions, specifically in two different forms. Factored form, which is the first example shown here, and then standard form, which is the second example. Let's look at factored form first. Now with factored form, when you have factors like this, each factor tells you what an x-intercept is, using the zero product property. So if f of x, the output is going to be equal to 0, meaning it's intersecting the x-axis, that means one of these factors, either the x minus 1 or the x plus 3, has to equal 0. So if x minus 1 equals 0, that means x equals 1 because you add 1 both sides to solve it. And if x plus 3 equals 0, then x has to equal negative 3. Solve that by subtracting 3 from both sides. So those are your two x-intercepts already, 1 and negative 3. So you already have 2 points for the parabola. Now you need to find the vertex. Now the vertex, because the parabola has symmetry, is halfway in between the two x-intercepts. So that's halfway between the two x-intercepts. And the equation for that line is x equals negative 1. So that means the vertex is somewhere on this line of symmetry. You know the x-coordinate, just don't know the y. So you can substitute the x-coordinate in here into the function and then solve it for the output f of x, and that'll tell you the y-coordinate. 2 times negative 1 minus 1 times negative 1 plus 3. And that's going to be equal to 2, negative 1 minus 1 is negative 2, so times negative 2, and then times negative 1 plus 3, which is 2. So 2 times negative 2 is negative 4, and then times 2 equals negative 8. So my vertex is negative 1, negative 8. Right there. So now I have the points that I need to draw the parabola. So it'll look something like that. That's graphing when you have intercept form or factored form. You find the two x-intercepts, the vertex is halfway in between, and you're good to go. So now let's talk about graphing in standard form. Now standard form is like this, or you can write it as f of x equals ax squared plus bx plus c. And the a, b, and c, those are the coefficients here. So in this case, a is negative 2, b is 4, and c is 9. So the x-coordinate of the vertex is going to be x equals negative b over 2a. That's true for any quadratic function in standard form. So to find the x-coordinate, you can do this, and that equals negative of 4 divided by 2 times negative 2, which is the negative of 4 divided by negative 4, which is simply 1, because 4 divided by negative 4 is negative 1, and then you have this negative sign here, so the opposite of negative 1 is 1. And then to find the y value of the vertex, you substitute the 1 into the function, kind of like with factored form. So f of 1 equals negative 2 times 1 squared plus 4 times 1 plus 9. And I'm being methodical here because I don't want to mess up on the algebra. It's really frustrating when you know what you're doing, but you make silly math mistakes, and that makes you have errors. So 1 squared is simply 1, so it's negative 2 times 1 plus 4 times 1 plus 9. Negative 2 times 1 is negative 2, 4 times 1 is 4, so plus 4, and then plus 9 equals negative 2 plus 4 is 2, and then plus 9 equals 11. Okay, that means my vertex is at the coordinate 1, 11. Okay, so right 1 and then up 11. Then what you can do is you can apply the special pattern for quadratic functions. So the leading coefficient is negative 2. So that means we're going to be going right 1, and then we're going to be going down 2 times 1 squared. And then right 2, down 2 times 2 squared. So that's going to be the pattern to get the other points in the parabola. And I'm going down because of the negative sign in front of the 2. So right 1, and then down 2 times 1 squared, which is 2 times 1, or 2. And 2 times 2 squared is 2 times 4, which is 8. So right 1, down 2, and then I'll use symmetry to put the point on the other side. Right 2, down 8, and then use symmetry. And that's actually enough points to draw the parabola. Okay, something like that. So that's graphing in standard form. And that's what you're going to be practicing in this lesson. That's the big picture.